Okay, looks like we're good. Alright, class, sorry I am absent today. I will hopefully be back tomorrow. But hopefully we can still continue with our lesson. Forgive me, it might not be as great as a normal lesson, but I'll do my best with what I have with this recording. So to start off, we have the question, what does the word parallel mean and what does the word perpendicular mean? So take a moment and think to yourself, what do you think of the definitions when you think of the word parallel? What do you think of when you think of the word perpendicular? Hopefully, what you would come up with parallel. So when we have two parallel lines, we have a line that goes in a certain direction and then another line that has the exact same distance away from it. So every part of these two lines are separate from each other. They're the same distance away the whole time. So they're parallel to each other because they're never going to get closer. They're never going to touch because they'll always stay that same distance away. Now perpendicular, hopefully I can draw some perpendicular lines. This is a little bit different. So the thing that separates perpendicular is because these lines will touch, but not only will they touch, but where they intersect, they will form 90-degree angles. So all of those angles in there will be 90 degrees, and I'm sorry my drawing is not good on here, but these will all be 90 degrees. So when we have parallel lines, those parallel lines will never touch. They'll always be the same distance apart. They'll never intersect. They'll never cross. They'll never get closer, never get farther away. Stuff we talked about before. Perpendicular, you have two lines that intersect, but not only do they intersect in such a special way that they form 90-degree angles with all of those angles formed. Unlike the lines we've seen in the past where we've had an intersection here and another line that goes like this. So obviously, this down here is not a 90-degree angle. And this one over here looks to me much larger than a 90-degree angle. What's unique about perpendicular lines is every single one of those angles is 90 degrees. So we're going to talk about these a little bit more today. So we're going to discover criteria and what is needed for two lines to be either parallel or perpendicular. But in order to discuss these lines, we need to think back to what the equation of a line looks like. So if we think back all the way to Algebra 1, and we think, what was our equation of our line? We had a special formula. Well, we had a couple special formulas, but the one that we use most often, and the one that we want to use today, are you working? Okay, that is y equals mx plus b. I'll do lowercase b because that's what we're used to. I'm going to put my multiplication symbol in here. All right. So y equals mx plus b. If we break these down to what each of these are, y was always the output, x was the input, m, that is what we called our slope. So I'm going to type slope. That was our m. So that was what we did, our rise or run, or y2 minus y1 over x2 minus x1, those things that we learned how to find in Algebra 1 and find the slope. That was your rate of change. If you're always increasing by 3, your slope was 3. Those are the things from Algebra 1 that we want to remember today. So our slope, and then b was our y-intercept. So whenever we graphed a line, we always crossed the y-axis at some point. The y-intercept was where we crossed the y-axis. So if you had a graph and you crossed the y-axis at 2, your b in this problem would be 2. If you cross it at negative 25, your b would be minus 25. And that was our y-intercept. So these were the two important things. So we always had y, which was our output, m, which was our slope, x was the input, and b was the y-intercept. And with these things, you could figure out the equation of any line that you had. You just needed that y and that b. All right. Is this still recording? Good. All right, just making sure. All right. So we'll need to know some of this information in order to discuss what makes two lines parallel and what makes two lines perpendicular. And so if we look at this situation, take a moment and just glance at these two problems, or glance at the parallel to start with, and see with that red line and those purple line, you have a set of parallel lines. What do you notice is happening when we graph those lines? What are some things, thinking back to your y equals mx plus b, what are some things you might notice? I'll give you a minute. If you need a little extra time, you can pause the video to keep looking. But hopefully, if we look at the slope of this line, if we think of it as rise over run, this is -2 over, or this is over 1, or a slope of, if I write it to the side, -2 over 1. That was the slope of our red line. If I look at my purple slope, I'm going down 2 over 1 again, -2 over 1. So in between all these 2 points, I'm always going over 1, down 2, over 1, down 2. Same thing with my purple line, over 1, down 2, over 1, down 2. So something unique about parallel lines is that their slope will always be the same. Anytime you have 2 lines that are parallel to each other, the equation of those lines will always have the exact same slope. If one is 3, the other one's going to be 3. If one's 5/3, the other one's going to be 5/3. The parallel lines will always, always, always have the exact same slope. So that's something we'll need to remember when we're talking about graphing parallel lines. Let's look at perpendicular lines. So I have these 2 lines that are perpendicular. My red one and my purple line. Try to take a minute and see if you can find anything unique about these perpendicular lines. Similar to how we saw that parallel lines have equal slopes, see if you can see anything about perpendicular lines. Once again, you can pause the video if you need extra time. But just like with parallel lines, we're going to look at the slope of this. So if I look at my red line first, my slope between 2 nice points, I'll pick these 2 points right here. If I look, this is 1, 2, 3, 4, so down 4 over 1, 2, 3 over 3. So my perpendicular, or for my red line at least, my perpendicular slope is -4 over 3. Now if I look at my purple line, and I look at the slope of this line, I'm going to take this point and my point up here. I'm going over 4, up 3. So if we were to do a rise of a run, that's 3 over 4. So 3 over 4. Now what do you notice about these 2 slopes? We have -4/3 and -3 over 4. So what we call these, when they're flipped versions of each other, we call those reciprocals. So you have a -4 over 3. If we take the reciprocal of that, or if we flip that fraction upside down, we get 3/4. Now, not only are we flipping the fraction upside down, but you're also changing that negative sign into a positive, or if it was a positive sign, we'd change it to a negative. You always want to change the sign. This is very similar, or this is the same thing that when we talked about reflections, and we were reflecting over a given line, we always had to take the reciprocal slope to find that line of reflection, or to figure out those diagonals that we were reflecting by. So if we start with -4/3, you flip that fraction upside down, so you get 3/4, and then you change that -4 to a +4, and we have 3/4 as our new perpendicular slope. And so perpendicular lines will always have reciprocal slopes. And so these are the 2 things we want to remember today. When you're looking at the equations of lines, parallel lines will always have congruent slopes. They'll always have the same slope. 1/3 and 1/3, 5/7 and 5/7, they're always going to be the same. It doesn't matter what they are, they'll be the same. So parallel lines will always have congruent slopes. Perpendicular lines, though, will always have reciprocal slopes. So in that last example, we had 4/3. Well, I guess these were switched. But we have 4/3 and -3/4. They're always going to be opposite sides of each other. So one will be positive, one will be negative. And then they'll be flipped fractions. So 5/3 and then 3/5, or 7/8 and then -8/7. I think that's what I said. So perpendicular lines will always have reciprocal slopes. Parallel lines will always have congruent slopes. And these are the 2 things we'll have to keep in mind. So you always have to remember parallel and congruent, perpendicular and reciprocal. And this will help us depending on which of these lines we're looking to graph. It's fun. So to start off today, let's just practice finding the parallel and perpendicular slope to each of these lines. So if we remember from y equals mx plus b, our slope is always that number right in front of the x. It's that m. So we have 3 over 2 for my x. So if I'm thinking, what is the parallel slope to this line? I remember from that last slide, parallel lines have congruent slopes. So in order to be a congruent slope, I just need to be the exact same. So I'm going to say 3 over 2 is my parallel slope. Awesome. Done. There we go. That's our parallel slope. Perpendicular slopes, if we think back a slide, perpendicular slopes have reciprocal slopes. So reciprocal means I have to flip it upside down, so that's a large 2. So it's going to be 2/3, but not only that, I need to change my sign. So if I have a positive 3 over 2, I need to make this a negative 2/3. So this is my parallel slope, and this is my perpendicular slope of each of those. So take a moment by yourself, see if you can do that second problem for you. You have y equals 5/3 x minus 7. See if you can figure out what is the slope of this line, and then what is your parallel slope, and what is your perpendicular slope. I'll pause the video, and hopefully, or you can pause the video, and you can take a moment to figure that out, and then we will reconvene, and hopefully you got it right. All right, so if you pause the video, hopefully you had enough time. Our parallel slope, if we remember, our slope is going to be 5/3, the number right in front of the x. Parallel is always going to be the same slope. So this, if our slope is 5/3, then this will also be 5 over 3. That's our parallel slope. Our perpendicular slope, once again, was always reciprocal. It's going to be the flipped version. So if I had 5/3, I now have 3 over 5 as my perpendicular slope. But if this is a positive number, I have to change the sign to make this one a negative, because my perpendicular slope will always have the opposite sign. Positive becomes negative, negative becomes positive. And so that's my parallel and perpendicular slope. All right, hopefully you were able to get that, and we can move on. All right, so on here, we're asked to draw a line. Actually, before you continue, pause the video, and go up to my desk and grab, there should be a worksheet that has this thing to start with. It says draw a line that is parallel and a line that is perpendicular to the given line and crosses through the given point. There should be this on my desk, hopefully. If not, then just follow along with the video. But there should be a worksheet with this on my desk. So grab that, come back, and then unpause the video. Okay, so hopefully you're able to find that worksheet. I hope. If not, it's okay. We'll talk about it tomorrow. I hope. If I'm back tomorrow. So what we're trying to do is we're trying to draw a line that is parallel and perpendicular to the given line that crosses through a given point. So you should have this first on your worksheet. This should be one of your problems on this practice. And so we're going to do this together. So basically, we need to draw a line that is parallel to this line and a line that is perpendicular to this line that passes through this point. So in order to do this, remember, we just have to think of what is slope. What is our parallel slope? What is our perpendicular slope? And then we can use that rise and the run. So I'm going to find 2 points on my line. So here and here look good. And I am going to figure out what is my slope. What is my rise or my run of this line? So if I look, that's a rise of 2 and a run of 3. So 2/3 is my slope. Now if I think my parallel line, parallels have congruent slope, so my parallel line will also have a slope of 2/3. So I'm given this point that my line needs to pass through. So from that point, I am just going to do that same slope over 3 up 2. Oh, and there's my line. I might not be able to go further. I'm going to try to use this line tool. That might help. So over 3 up 2. It looks like this is a parallel line. Oh, one moment. Sorry about that. Alright, so that was our perpendicular slope, or I'm sorry, that was our parallel slope. We used that same rise over run to draw that line, and that is parallel for original line. Look, it's nice and parallel, all those same distances apart. It's great. All right, well, now we're going to do the exact same thing, so we're going to try perpendicular. So we have 2/3 of our slope of our line. If we remember, our perpendicular slope is the reciprocal. It's going to be the flip version, so that's going to be 3/2 now. So you can see that. Sorry, my 2's probably down there. But remember, we have to change the sign, so rather than just being positive 3/2, it's going to be negative 3/2. And now, starting from that same point that I want to draw my line, I'm going to use this new slope. So I need to go down 3/2, as my slope says, and this is where my point's going to be. So I'm going to get my line tool, and starting from my point, I'm going to go to my other point, and then I'm going to continue that farther just to make sure that looks good. And this will be my new line. I could also go another backwards, up 3/2, and I know this is going to be another point of my line, and so I'm going to click and drag this up there as well. So that we now have drawn a line that is perpendicular, and a line that is perpendicular and a line that is parallel to our original slope. So walking through these steps once again. Look at your original line, that red line, the blue line, whatever line you have. Look at that original one. And look, okay, what is the rise in my run of my slope? And figure that out from the line. So we saw that was 2/3. For your parallel line, you're going to do that same thing. So we're going to go over 3/2, and that's your new line. For your perpendicular line, we're going to do the opposite. You're going to go down 3/2, that reciprocal slope, and that is our perpendicular line. So see if you can do that for the next problems on those worksheets, and then we'll talk about this more tomorrow, and we'll practice this tomorrow. All right, hopefully you have a good rest of your day, and I will see you tomorrow.